6.5 notes coming right here. Talking about trapezoids, ladies and gentlemen. Trapezoids are definitely a little different. At the request of some of you, today's pointer will be, that's right, the lightsaber. So you got a quadrilateral with exactly just one pair of parallel sides. Key word right here is one pair. Okay, so for example, if we're looking at this picture right here, you've got two base sides here. Okay, they're basically what the trapezoid would be setting on, and then these other sides here are called legs. All right, and they're not always what's parallel, but it just depends. This is also a trapezoid. It's called an isosceles trapezoid. Remember, isosceles triangle comes from having two equal sides. You got the tick mark here and the tick mark here. So just one pair of sides that are equal length. Okay, that's an isosceles trapezoid. Now, looking at example 1, we have, let's zoom in here just a little bit. So they want us to find the measures of this trapezoid, okay? So PQRS, it's an isosceles trapezoid. You can see it's marked with a tick mark right here. They're the same length. Find the missing angle measures. Okay, so let's talk about a couple theorems over here first before we really do that. I can't stand the one that's tilted. And let's go with this. Okay, here we go. Ah, it's perfect. There we go. So if you got a trapezoid that's isosceles, which the one in our example is, it says each pair of base angles are congruent. All right. So if we go back over and look at this again, all right, the base angles are going to be congruent. Now, this is a base side here as well as here, okay? So if this one's 50, base angles are congruent. This one over here has to be what? I hope you're shaking your head and saying 50 degrees, okay? Now, so angle R is 50. And I'll try to write a little neater for those of you out there that are criticizing how neat I write. All right. Now to figure out what angle P and angle Q would be, think about it for a second. How many degrees are inside a quadrilateral? If you're thinking 360, you're right. So we've used 100 so far. So I'm just going to take 360, subtract that 100 degrees that we've already used. That leaves me with 260 degrees. Now, does that mean that both these angles P and Q are 260? No. Together they're 260. So now take this 260. This would kind of be like step 1. Step 2, take 260 and divide it by 2. Mental math moment here. What's half of 26? Be 13. Add a 0. So these each are 130 degrees inside there. So P is 130 degrees and Q is 130 degrees. Again, I got that because they've all four got to add up to 360 degrees. Okay? If you're not sure of that or you didn't catch it, just rewind and watch it again. You can listen to all my geniusness a little bit more. Talk about example, actually before I talk about example 2, this other theorem over here on the side, it's the direct opposite of this one up here. This one said, okay, so if you got an isosceles trapezoid, so two sides are equal, the base angles are congruent. This one just says if it has congruent base angles, well, then it's isosceles. It's just a complete reverse of the other. So nothing to really write home about on that one. The last example here wants us to find the midpoint of a mid-segment, or excuse me, find the mid-segment. So the mid-segment is this D to G right here, okay? They want us to find the length of that mid-segment of the whole trapezoid, okay? So here's your formula that you're going to kind of use. What you're going to do is to find mid-segment, I'll just go mid-seg equals, take base 1 plus base 2 and divide by 2. Now, which one's base 1, which one's base 2, it really doesn't matter. You're adding, so you're going to get the same answer. So let's say this is base 1, this is base 2. So to find my mid-segment, I'm going to take 20 plus 8, and then divide that by 2. So 28 divided by 2, and our mid-segment is 14 units. That's his length. That's from D to G. All right. So you may have some questions asking you how to find that mid-segment. That's all you got to do is add these two bases together, divide by 2. Okay? So in summary, all right, we've talked about trapezoids. Again, trapezoids have one pair of parallel sides, just one. So like right here, where's your parallel sides? And then these other sides here are called legs, okay? And then we also have isosceles trapezoids with two sides that are equal. Generally, it is the legs. And we also talked about the inside measures, how they got to equal 360, and that the base angles, remember the bases are the parts that are parallel, okay? Those angles are always going to be congruent to one another. And then lastly, we just talked about the mid-segment. How do we find that mid-segment, the length of him? All right, he's directly in the middle of FG and CE down here, all right, splits them in half. So those two pieces are equal to each other, and then the length of him, we add them and divide by 2. Thanks for joining us on today's show. That was 6.5 notes.